Okay, this is the second part of the review introduction to Chapter 12. So 12.0, we're talking about special right triangles in this section. So Scarecrow's first thought with a brain. You guys have seen The Wizard of Oz, right? Do you remember what Scarecrow's first thought was? All right, let's see.
A very mediocre commodity. Every useless animal creature that crawls on the earth or sleeps through sliding seas has a brain. Back where I come from, we have universities, chiefs of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitas Art Pluribus Unum, I hereby confer upon you the honorary degree of PhD. PhD? Doctor of Psychology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
So Scarecrow's first thought is the Pythagorean theorem, but he doesn't quite get it right. Okay, so I'm not sure what kind of brain that the Oz gave him, but he's got to work on the Pythagorean theorem a little bit, right? But he does talk about isosceles right triangles, and that's what we're going to start out talking about. This is our first type of special right triangle, an isosceles right triangle. All right, so it says here, use the Pythagorean theorem to find the hypotenuse of each isosceles right triangle. So we need to do that. First isosceles right triangle, the legs are 1. We have to find the hypotenuse. 1 squared plus 1 squared equals c squared. Well, 1 squared is 1, right? So 1 plus 1 is 2. C squared equals 2. Take the square root of both sides. C equals the square root of 2. So we'll put the square root of 2 here. Second isosceles right triangle, the legs are both 2, so we have 2 squared plus 2 squared equals c squared. 2 squared is 4. So c squared equals 8. C equals the square root of 8, which can simplify to 4 times 2. The square root of 4 is 2. So this is 2 square roots of 2. So we'll do 2 square roots of 2. In our third triangle, the legs are 3. So we'd have 3 squared plus 3 squared equals c squared. 3 squared is 9. 9 plus 9 is 18. So 18 equals c squared. C equals the square root of 18. But that can be simplified 9 times 2. And the square root of 9 is 3, right? So 3 square roots of 2 equals c. Now, do you see a pattern that is happening in our table? So the pattern that we're seeing, the length of the leg times the square root of 2. So if you look at the first one, this is 1 square roots of 2. If you look at the next one, this is 2 square roots of 2, obviously. Then we have 3 square roots of 2. And so for our final triangle with the leg length of L, we would have L square roots of 2. And this leads us to a shortcut. In an isosceles right triangle, if the length of the legs is L, then the length of the hypotenuse is L square roots of 2. That brings us to our next special right triangle, a 30, 60, 90 triangle. Bisecting an equilateral triangle gives you the 30, 60, 90 triangle. Here we have an equilateral triangle. We know that it's equilateral because we can see that the angles here, 60, 60, that would leave 60 for this angle. All the angles are 60 degrees, so all the sides have to be congruent also. Right? And what we're doing is we are bisecting this angle. We're taking half of the triangle, and we now have our 30, 60, 90 30 degrees, 60 degrees, 90 degrees. Now it's our job to find out the relationship between the side lengths. Now let's say that on our equilateral triangle, each of the side lengths was 1. Well, that means that when we split the equilateral triangle, now this side DB is going to be 1/2, right? Because it's half of what was AB in the equilateral triangle. Well, CB, which is now the hypotenuse of this right triangle, is still 1. That hasn't changed. The question is, what's the length of the other leg, CD? Well, let's use the Pythagorean theorem and find out, right? We have a leg squared plus another leg squared equals the hypotenuse squared. Square 1/2, you get 1/4. Square 1, you get 1. Now we solve for B. Subtract 1/4 from both sides, you get 1 minus 1/4. 1 minus 1/4 is 3/4 squared. Now take the square root of both sides and we get B equals the square root of 3/4, which will be the square root of 3 over 2. Right? Because the square root of 4 is 2. Right? So our other leg here is the square root of 3 over 2, which could also be thought of as 1/2 times the square root of 3. And if you look closely and think about the last example that we did, look what's happening here. 1/2, 1/2. This leads us to our next conjecture. We're actually going to skip that. In a 30, 60, 90 triangle, if the shorter leg has length A, right there, and the hypotenuse has length 2A, right there, and the longer leg has length A square roots of 3, right there. It is important to remember that the shorter leg will be opposite the 30-degree angle because that's the smaller angle, and the longer leg will be opposite the 60-degree angle because that's the bigger angle.